It is pretty tough to have a VPN client connect to a VPN server if there's no client software. So in this video, I'd like to share with you a few options that we have about that software on the individual PC that we can use to build remote access VPN tunnels. So for this discussion, let's imagine we have this router configured as a VPN server, meaning it's there ready, willing, and able to accept VPN connections. And again, the VPN server, the head-end device, could be any device that supports those features. Maybe it's a firewall, maybe it's a router, maybe it's a dedicated appliance. And in this case, we're going to use this router as our example. Now, we have a user like Bob who is home or at a conference. He's connected to the internet, and he would very much like to build a VPN tunnel between his computer and the VPN server. And that'd be an example of a remote access virtual private network for Bob. Now, as I see it, we have two big challenges in getting Bob to connect. One is we need to have the software that's present on Bob's computer, and two, it needs to be configured. So we need to have him basically launch the software, have the software come up, and try to connect to our VPN server. And the intent is, if we can just get a minimal configuration on Bob's computer and build the connection, the goal would then be to push any other details like split tunneling and other details down to Bob's computer so he can be a happy participant on the network. Also, as part of the VPN, one of our options is to give Bob an address. So up here, if we have the 10.16.0 network, we could create a pool of addresses like 10.16.1.0, maybe that subnet, and we can actually virtually hand out IP addresses to our VPN clients when they connect. So Bob, using his VPN, would logically have an address like 10.16.1. Let's give him 100, that he can use as he interacts with other devices on that network. But in reality, every time he's sending packets back and forth between any of those devices, that traffic is going through the VPN tunnel and then being routed from that VPN server into the network using Bob's source address. And then for the replies back, the VPN server would take those data packets, encrypt them, and ship them back over the tunnel protected to Bob, and then Bob's client would decrypt them and then process those packets. So because Bob is running on a Windows computer, let's take a quick look at some of the VPN client options that exist in the native operating system. So as a word of caution, you and I probably do not, I repeat, do not want to change any settings on our personal device, whether it's a Mac or a Linux or Windows. If somebody has set up a VPN and it's all working, we'd want to leave that in place. So in that light, I've got a virtual lab with a Windows 10 computer. You can click on the link. If you're logged on to CBT Nuggets, click on the link for the virtual lab, go to the client PC, and you can follow along and taking a look at our options for the VPN client services that are built in to Windows 10. Now, on a Windows 10 machine, there's lots of ways to get to the VPN section. One way would be to click on the Windows icon, the bottom left-hand corner, and then here's the gear icon for settings. If we click on settings, and then from here we have a section for network and internet, including VPN right there. So if we click on that, and this computer is in a sandbox up in the cloud at the moment, but we can still go to the VPN settings here. So on the left-hand side, click on VPN. And currently there's no VPN connection set up, but if we click on the plus symbol to add a VPN connection, we can go ahead and specify the VPN provider. And if we select Windows built in, then we can give it a name like test. And for this example, I'm going to use 23.1.2.3. Let's imagine that's the VPN server that we want to connect to. And then for the VPN type, we can say automatic, where it'll just negotiate, or we can specify the type of VPN connection. Point-to-point protocol, L2TP with IPsec with certificate, L2TP with IPsec with a pre-shared key, secure socket tunneling protocol, IKE version 2. So we'd choose the protocol that we want to use, and then because we selected pre-shared key, we'd put the key in. Let's say it's Cisco 123 or whatever the key is. And as we scroll down, it's asking us about the type of sign-in information, and we'll use username and password, and it's asking for a username, our name. We'll continue scrolling down, and then we'd put in our password. And if we didn't want to put our username or password here, it would just prompt us when we connect. And I would encourage you to not store passwords, especially for VPNs. Please don't include that as part of the profile unless that's part of your company policy to do so. And then click on Save. And now we have this test VPN connection. So if we click on it, we can go ahead and then click on Connect, and it will try to connect to that server, negotiate a tunnel, and we're on our way. So that is an example of some built-in remote access VPN client functionality on a Windows 10 system. However, in a Cisco environment, if we're doing VPNs for remote access, it's very likely we want to use Cisco's client, which is the Cisco AnyConnect client. Now, one of the really cool things about the AnyConnect client is that to deploy this, what we could do is we could have our users go to a URL with HTTPS And then when they connect and authenticate, it would then prompt them to go ahead and download the actual software for the install. So getting the software to the client has been made very, very easy with Cisco AnyConnect. And then once the software is installed, we put in the URL we want them to go to the head-end server. They click on connect, and it builds the VPN for them, asks them to authenticate along the way, and then to disconnect, once it's up, they simply click on disconnect, and that tears down the VPN tunnel. With the VPN tunnels also, there's lots of options that can be set. Most of these are going to be set from the head-end device and pushed as policy to the client, including, do we want to build the VPN automatically when the AnyConnect client comes up? Do we want to block connections to untrusted servers, and so forth? It has information about the VPN that's currently in place, and here we have IPv4, we have split include, which implies that the client who's running this VPN is sending some traffic based on destination IP address over the tunnel, and everything else is being sent in the clear. Also, it's showing the IP address that's been assigned to this client for this virtual private network connection that it has to the network. It's also going to show the VPN server that we're connected to right here. On the route details, it has information about the split tunneling. So effectively, anything in this list, if traffic is leaving the PC that's running the VPN client, any traffic leaving the PC for any of these destination IP addresses is going to go through the tunnel, and everything else that's using the default route is not going to be sent through the tunnel. So this is an example of what's happening with split tunneling when that VPN client is up. Another cool feature here on the firewall tab is that we can actually push to the AnyConnect clients restrictions and firewall services to protect that client even further. And then in the message history, if we're troubleshooting or want to see the events that have happened, there's logging that's going on that we can look at. Also, check this out. I love this. The AnyConnect downloader is performing update checks and performing any required updates. And why that's so stinking cool is because we can update the software at the head-end device, and then when clients connect in the future, if there's a newer or updated version, that can be automatically downloaded to the client. So we don't have to worry about manually upgrading remote access clients. It can happen automatically. So in a Cisco environment, it makes a lot of sense to use the Cisco AnyConnect client because it's not just able to do lots of different protocols for remote access VPNs, which it can, but it can also be part of an overall security posture for that computer, integrating anti-malware support, also integrating things like 802.1x, which is a fancy way of saying proving who a computer is before you let it on the network, in wireless networks or with switch networks. So the short story is there's a lot of additional features and options that we have besides just VPNs that we can use with the Cisco AnyConnect client. And that's what makes it so powerful. And over the years, it has gotten better and better and better. So in this video, we've taken a look at some options regarding building remote access VPNs from a client computer up to the head-end device. Some of those could be built into Windows. Others could be using a third-party client like the Cisco AnyConnect. And the goal is to protect individual data from that computer as those packets leave that computer through the remote access VPN. So I am glad that you joined me in the video. I hope this has been informative for you, and I'd like to thank you for viewing.